How many planets are in our solar system? The typical answer these days is 8. But that might not be the best possible answer, and the story goes much deeper than just one particularly lovable ball of ice out past Neptune. In fact, there could be well over 30 planetary bodies scattered throughout the solar system. Let's explore. What is a planet? The International Astronomical Union, or IAU, has a 3-part definition of what makes something a planet. First, it has to orbit the Sun. Second, it has to be large enough to make itself round by its own gravity. And third, it has to have cleared the neighborhood around its orbit. Essentially, the IAU planets are the largest objects orbiting the Sun that define regions of our solar system. You could talk about a near-Earth asteroid versus a Mars-crossing asteroid. For instance, 8 planets make this cutoff, which you're probably familiar with: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. The IAU planets are good at defining zones of the solar system, but it's pretty easy to find holes in the IAU's 2006 definition. If you were at all aware of planets in 2006, you'll already about the Pluto controversy. Pluto is a gravitationally rounded icy world, which has not cleared its orbit, being orbitally bossed around by Neptune. Even though it was considered a planet for decades, the IAU declared Pluto to be a dwarf planet since it meets the first 2 criteria and not the third, along with a handful of other objects that meet the same standard, including then newly discovered Eris, which is more massive than Pluto but slightly smaller in volume. There's also the fact that the neighborhood criterion makes Mars less of a planet than Mercury, not to throw shade at Mercury, though it might actually appreciate some shade. In any case, there are reasonable arguments for and against the IAU definition, but for the purposes of this video none of this actually matters. You see, if you study planetary geology, that is, geology without the geo part, then it makes more sense to classify planets not as objects that define a region of the solar system, but rather as just anything that's the right size for geology-ish things to happen to it. This includes having planetary layers like a core, a mantle, and a crust, and that second criterion of being rounded by its own gravity. Alan Stern, the principal investigator of the New Horizons mission to Pluto, and Harold Levison created their own definition of planetary bodies in 2002 reflecting these parameters. First, a planetary body has to be large enough that its shape is primarily determined by gravity. And second, it has to not be large enough to ever undergo nuclear fusion and become a star or a brown dwarf. Planetary bodies that orbit a star or stars are planets, ones that orbit a larger planetary body are planetary-scale satellites, and ones that do not orbit either are unbound planets. The planetary bodies. So, what are all of the solar system's planetary bodies? All of these guys. We have the 8 IAU planets, nice to see you again, and at least 3 former planets: Pluto, Ceres, queen of the asteroid belt, and the Moon. Ceres, as the first asteroid discovered, was grouped as a planet for quite a while after its discovery in 1801, and asteroids generally were considered planets perhaps as late as the 1950s, at least according to Alan Stern. The Moon, for its part, was considered a planet in the ancient Mediterranean, with the word planet coming from the ancient Greek word pailamdid alpha nutoeta meaning wanderer, and encompassing all celestial objects that wandered through the sky, including the Moon and the Sun. These 3 former planets each represent one of the 3 categories of planetary bodies other than the IAU planets, Ceres leading the large asteroids, Pluto leading the outer solar system iceballs, and the Moon representing the moons. The big asteroids. Let's start with the asteroids. Other than obviously round Ceres, the other big asteroids, including Vesta, Pallas, and Hygeia, are borderline planetary bodies, being not obviously round themselves but bigger than some other gravitationally rounded objects in the solar system. We know a lot about Vesta in particular from NASA's Dawn space probe, which visited Vesta in 2011, and from meteorites that originated on Vesta and have fallen to Earth. Vesta probably has a separate core, mantle, and crust, and was probably round in the past when it was warmer and more flexible, before being knocked out of shape by impacts with smaller asteroids. One such impact left the giant Rhea Silvia crater, named for the mother of Romulus and Remus, the legendary founders of Rome. The central peak of Rhea Silvia, formed by uplift after the impact, rises 14 miles, or 22 kilometers high, rivaling Mars's Olympus Mons. The icy dwarfs next. Let's turn to Pluto and the other trans-Neptunian objects, including Eris, Makemake, and Haumea, the IAU recognized dwarf planets along with Ceres, and the probable dwarf planets like Quaoar, Sedna, Gaumont, Orcus, and Salacia. Pluto is the only one of these that's been studied up close by the previously mentioned New Horizons probe led by Alan Stern, so we don't know much about the others other than their general size, shape, and color. Even these can tell us that, for instance, Makemake is very reflective and Haumea has spun itself into being an ellipsoid. We also learned Haumea has a ring by watching it pass in front of a star. Many of these icy dwarf planets lie in the Kuiper belt, a band of objects just outside the orbit of Neptune, but some are even further out. Some other dwarf planet moons like Eris's moon Dysnomia might be round as well, but we're not sure. Conclusion: so with 8 IAU planets, 5 recognized dwarf planets, 5 likely dwarf planets, 3 roundish giant asteroids, and 19 round moons, our solar system hosts at least 32 to 40 planetary bodies, and maybe a lot more. Each one is its own case study on how worlds form and evolve, and no two will tell exactly the same story. Knowing that there are so many worlds out there to explore is exciting for all of humanity, including, of course, Alan Stern. Be sure to leave your feedback in the comments, and subscribe if you want to see more like this. And as always, thanks for watching.